This talk is about built-in application whitelisting with Windows Defender application control. Just curious, do a lot of people here, how many people have like application whitelisting deployed in your environment? Anyone? One? Is that a raise your hand? Two? Sweet. Have you guys played with Defender, or excuse me, Device Guard or Windows Defender application control? Do you guys regret having app whitelisting deployed? No? Cool. Main reason I always like to ask that before this talk, or a talk about this, because if you're in my workshop, you kind of heard the spiel yesterday. I love app whitelisting. I think it's probably one of the best defensive technologies out there that can be used in an environment, and it's a lot of work up front, clearly. Designing policies, creating effective rules, making sure people can still do their job. But I've never met an organization that's after they spent that time to deploy it, that's hated or regretted doing so. So I was always curious. My name is Chris Truncer. I'm the co-founder of this security company called 40 North out of Colorado in the US. I am our offensive security and red team lead, and I work on a variety of different open source projects. There's like Veil, Eyewitness, and one of the tools that we'll demo today is Wimi Implant. So what's this talk about? This talk is about WDAC. What is it? So WDAC is Windows Defender Application Control. If you've heard about this referred to before, it used to go by another name called Device Guard, which is what you'll probably still hear me refer to it throughout here because I'm so used to saying that. We'll talk about code integrity policies. These are basically the rules that are going to be enforced within your environment on computers that that make a decision if an application is trusted and allowed to run or not. We're going to look at how WDAC can be deployed. We're going to talk about modifying and enforcing different code integrity policies. So how do we change the rules once they've been deployed? We're going to look at how an attacker could target Windows Defender application control, and then I'm happy to answer any questions. I really love giving this talk because I'm more of an attacker by just background and everything that I've done, and this is really kind of my first or only semi-defensive talk, but I like talking about this a lot because I believe in this sort of technology. All right. So Windows Defender application control. What is it? Well, it's a defensive technology that's built into Windows 10 and Server 2016 by default. It's Windows 10 Enterprise, but it's there. And the nicest part about it is completely free. So if you already have 10 and Server 2016 in your environment, you can utilize WDAC and have it start protecting your systems. It can be thought of as an application whitelisting solution plus some additional benefits. And it's a move away from antivirus where we don't have just antivirus that just scans for bad stuff and if it doesn't find it, it's good. With this, we only trust what we say that we trust. And if it's not an application that is trusted or a digital signature possibly that we don't trust, that is trusted, then it's not allowed to execute. So WDAC is more than just app locker. So app locker generally people usually think within like userland, different directories that rules are enforced upon that allow either applications or different libraries possibly loaded. Windows Defender application control can do all of that. Plus it also hooks into like what we call kernel mode code integrity, where you can enforce different rules that either allow or deny drivers on your system to be loaded as well. And I'll show an example of when that's gone bad on me before. The biggest thing about WDAC is almost all of its rules that it enforces on a system are based on digital signatures. So digital signatures are really important, but Windows 10, everything's supposed to be digitally signed, at least at the kernel level for like drivers. Like I mentioned, it is heavily relies on digital signatures, but what happens if you're in an environment where you can't digitally sign, or like an application is running that's required by your employees that is not signed at all? Well, you can create something that's called a catalog file. And the only difference, or the issue with catalog file is every time that application is updated in the future down the road, you have to regenerate a new catalog file and then regenerate a new set of rules to allow that program to run. So the nice thing with this, though, is if you do your trust decisions and your rules based on digital signatures, let's say you trust everything signed by Google. Anytime Chrome, let's say, is updated, your rules account for that and automatically trust it, assuming that Google Chrome is still being signed by Google's root CA that you trust. So code integrity policies, like I mentioned, contain the rules that are enforced on your system. The operating system, so Windows itself, enforces these rules to allow an application to run, or a driver, or a DLL to be loaded, or not, because it's not trusted. So the other thing that it can do is, if you don't have this in what's called enforcement mode, it can just silently sit there and log and audit what's being loaded. So you may have rules that you want to deploy within your environment, but you don't know how mature they are yet, and you want to see how well do these work in this current configuration if I were to deploy it domain-wide. Well, you can just deploy something, your rules in audit mode, and it'll create event log events that you can monitor to see, okay, maybe I did miss something that I need to update my rule set before I allow rules to be enforced domain-wide. Code integrity policies, you can kind of think of are not really a blacklist. It's whitelist only, but that's kind of a lie, where we can actually kind of get around stating, I don't want this to run, by making a rule in a very specific way, which we'll show in just a second. You can kind of think of this, though, as more as a whitelist plus plus, because that's really what it's designed for, where you only state what's trusted versus don't trust something. So the other thing that Windows Defender Application Control does is it enforces something called PowerShell Constrained Language Mode. If you were in my workshop yesterday, you heard me talking about this, but people heard with, or played with, or unfortunately tried to code or do anything in constrained language mode. It's a very locked down version of PowerShell. If you remember, Windows RT, the operating system that was designed to go on the original Windows tablet, that was the version of PowerShell that was coupled with it that was designed to run on that tablet. And what it is, it's supposed to be an administration-only version of PowerShell, where you can run different PowerShell command lists that let you administer a system, such as modifying AV configurations, just basic system administration tasks. The other thing, though, that constrained language mode enforces is it only allows you to use very specific data types, and it has a whitelist of the data types that are allowed. If let's say some PowerShell command you're trying to run in any way operates with a non-allowed or non-trusted data type, then it will fail. So what does that look like? So here's some basic examples. In this case, we're just trying to perform a base 64 encoding of a string, which seems very benign. In this case, we're just trying to do the square root of the number 9. But it uses data types that aren't allowed, and we cannot actually run these commands within PowerShell constrained language mode. It's just going to be blocked. Yes? If you trust your script and you build it into your rule set, you are allowed to do that. Yep. Sorry, the question was, can you sign a script and then use it and have full PowerShell access? All right, so I mentioned code integrity policies a couple times. I know it's a little abstract. I'm about to show you an image of what these look like. The big thing is that code integrity policies, like I mentioned, are the rules that are actually enforced in your environment. So you can kind of build your set of rules or your code integrity policy on a system, and we'll talk about a couple different techniques to do so, and then deploy it within your environment. The code integrity policies start as an XML file. That's the easiest way. It's kind of the semi-human readable format where you can look at it, see how it works, what it looks like. But then in order for Windows to actually use your code integrity policy, like everything Windows, it wants it in some sort of a binary format that's easier for it to ingest. So here's an example of what these rules look like. So this is just at the very beginning, but in this case we have different rule sets. So right now, audit mode is actually enabled in this environment, which means it's not actually enforcing the rules. It's just going to be logging any sort of application that tries to run that wouldn't meet the rule set. There's different advanced menus. This is saying that user mode code integrity is on, so it's monitoring user level applications that are running. Here's where I was talking about a way that you can kind of get around a blacklist. So this is actually from Matt Graber's GitHub. He has a list, he has a GitHub that contains rules to prevent applications that are known to allow application whitelisting bypasses from running on your system. And the way that he does this is You can see, like, so here's MS Build. Like, this is a known application whitelisting bypass tool. We have WinBag right here, CDB. BG Info is actually susceptible to an application whitelisting bypass until a few versions ago. And the way that these rules are set up is you can see right here, this minimum file version is massive, right? 655.35, 655.35, 655.35, and 655.35. And all of these are actually the same until we get down here into BG Info. And the way that these rules and what this basically says is you're supposed to deny MS Build from running until it surpasses this 655.35 and so forth version. Well, this is the maximum file version that is allowable on a Windows system, so this will never surpass this version. Therefore, MS Build is always blocked. And so that's kind of how we're getting around creating a blacklist of rules. If you notice down here, though, BG Info does not have that same version. That is because it is after this version where the patch was applied and they are no longer susceptible to an application whitelisting bypass. So this is actually allowing BG Info, assuming you are not running a version that is susceptible to an application whitelisting bypass. Here's kind of what I talked about again, another just image of a XML version of this, the code integrity policy. Again, here showing like audit modes enabled. This doesn't have the different file rules in here that we just showed for this screenshot. However, down here is where you can start to see, and it's unfortunately cut off a little bit, the code, the PowerShell commandlets are picking up the digital certificates that are allowed and trusted by you. And this is creating a rule saying, hey, this specific PCA certificate, which is the Microsoft Windows Production PCA 2011 certificate, is allowed to be on the system. So what this means is basically any single application that's signed by this certificate is allowed to run. So now that we kind of have an idea of what a code integrity policy is and what it looks like, how do you go about creating one? Well, the nice thing is that it's fairly easy to do so with PowerShell. PowerShell has a couple different commandlets that we can use to create this code integrity policy. And basically 4 of these will get us exactly what we need. So the main one is going to be this new CI policy or new code integrity policy. This is, go figure, it scans your system and creates a code integrity policy based on the different attributes and what you tell it to run, the different flags that you're basically going to provide it. The convert from CI policy is a commandlet that takes the XML rule set that I just showed you and it converts it into a binary format that Windows can use. Set rule option specifies or allows you to change and set different rules within your code integrity policy. So for example, like back here, we have audit mode is being enabled. You can use, and that's a rule, we can use the set rule option to change that and do not allow audit mode, which would mean that it's actually enforcing the rule set. And then finally, we have merge CI policy. Merge CI policy is, let's say you have 2 different rules, like you have your initial one, and then you have one that you have updated rules based off of what you may have missed. You can use this commandlet to merge these 2 different code integrity policies together, so your rules, and create one master one that's enforced. So when it comes to creating code integrity policies, there are 2 primary strategies that people seem to kind of follow. It could be to build a code integrity policy based on a gold image system. So this is usually what we'll see in an environment where application whitelisting is deployed. And what people will do is you'll take a normal workstation, you'll install the applications that an employee normally needs to run to do their job, and then once they have everything installed that they need, they'll perform some sort of scan or some sort of sweep on that system. And they'll base rules on what's allowed to run based on the applications that are currently on that system. Another method of doing it, and Matt Graber kind of really talked about this and made blog posts about it before I've seen anyone else do it, is kind of create a default deny all policy where he basically he installs, I believe, the applications that he needs on a system, but trusts nothing on it. And then will only run the applications that he needs. And then as his programs run and everything's blocked, he slowly adds rules in until everything is needed. So let's dive into both of these strategies to kind of learn a little bit more. Let's look at gold image policies. Well, the first step on this is to install all software that's needed to for the system to create the rule set that you want, right? When you're creating the code integrity policy, since all software is installed, all of it's going to be allowed to be trusted and allowed to run. And that's, again, unless it's not signed, in which case you need to create a catalog file. Assuming that that's not an issue, and everything in a perfect world is digitally signed, if you run this commandlet new CI policy, it will pick up everything that you need, and you will be able to have like your rule set based off of your gold image system. So let's take a look at how that, what it looks like. I can move this image over there. Alright, so basically all you're doing, this is really, the first part is very fast, is we're just starting PowerShell in an administrative context, and all you need to do is call this new CI policy. So in this case, I'm assuming that I have everything that I need and want on this system, and I want to scan this and create my rules. Again, this will actually go ahead and create the rule set for me, so I don't need to do it. It makes life a lot easier. I'll talk about what these different flags mean real quick. Okay, so when you create your code integrity policy, this level is probably one of the biggest decisions you'll need to make. This is saying, at what level do you want your rules to be created? Device guard, Windows Defender application control has multiple different levels that you can enforce rules on. You can enforce rules by a file hash. A lot of people usually will think that that's the most secure, that it's an easy way to just only allow what's allowed to run. The issue with that, as I'm sure as everyone here knows, is the second that any application is updated in any way, the hash is going to change. Once that hash changes, your rule set no longer applies, and it would be not allowed to run. In that case, you need to create a new policy. Well, that's easy for one-off scenarios when you're doing this in a lab, but if you think in a domain or enterprise environment, the management overhead that would require is just not acceptable. It would be a little bit too much. So this is the PCA certificate level. So you can think of this as kind of like the highest certificate or higher certificate in the certificate chain. It's not the lowest level certificate and when it comes to digital signatures. This will go ahead and go through and pick up the digital signatures of any application that it can, and it will create a rule allowing the signatures that it identifies. So this is where the flexibility of device guard comes in as a little bit nice, as a nice thing to be able to use, because anytime any application, like I mentioned before, is updated, as long as it's digitally signed, it's just trusted, and you don't have to do anything else beyond that. The user PEs, what this means is it's going to scan user level applications. If you don't have something like this set, then it is only going to look at like kernel drivers and allow the drivers you already have installed on your system. So if you want to actually enforce this in your environment and make sure like user land applications have rules created for them, then you need to specify this user PEs flag. After this, I believe this is going to be the file path is just setting the output of where we want the XML file to go to. Yep, so here we have like the initial scan.xml. This is pretty much, if you want to start with like a bare bones like base, if you're first learning how to create this, like this is what I would do, because it'll do a scan. Now this part, this is it actually going through and scanning your entire system. It's looking at every single file, and it's doing a lookup, in this case, to find the certificate that should be trusted. The only issue with this is I've had to scan like on almost a clean system with minimal applications installed, doing this, and it's taken like 3 days. It's a ridiculous amount of time, and it's because I actually talked to Matt Graber about this, why he thought this was happening, and he believes because, and it makes sense, that it's expensive from a computational like standpoint to consistently do lookups on signatures for every single application, DLL, driver that's on a system to make sure you have the certificate required to create the rule set. So this could take a little bit of time. Just be aware of that if you're doing this. Oops. So the only issue with this is if we're trying to create this gold image policy, kind of like what we were just demoing, there's an issue. This gold image policy is going to pick up all of these different Windows application or Windows binaries that are susceptible to application whitelisting bypasses. I mean, everyone remembers like regsvr32 squibbly-doo from Casey Smith. He actually found all of these, MS-build, install-util. Because we're doing that gold image scan, if we were to create our rules and enforce it just like I just demoed, then that's actually going to trust all of these applications, and you can just subvert your application whitelisting rules by leveraging one of these applications for a bypass. And that's what I just said. Let's go to default deny all policy. This is basically like the polar opposite of what we just talked about. This is going to just default deny everything running on a system. The best way to kind of go this route, if you wanted to test this, is to use Windows Defender application control in audit mode. And that's because when something's in audit mode, like I mentioned before, it's not going to actually enforce your rule set. It's going to let every single thing run. But if there is an application that would have been blocked that isn't because it's in audit mode, it'll generate an event log event. And you can use that to create new rules based off of what you missed. You're still going to install the programs that are needed for your workstation to do your job, because you want to generate rules for any application that's needed in order to get your work done. Because if you don't generate that event log event for it, then it would still be missed and blocked. So the nice thing is, rather than blindly trust everything, we're only going to trust what we absolutely need to get our work done. If we're not running MS-build, if you don't need to run MS-build or install util or regsvr32 or any other like application whitelisting binary, or a binary that's susceptible to application whitelisting bypasses, then don't run it, and it's not going to be ever trusted in the first place. So again, it just comes down to why allow untrusted code to run when we can just block it from the beginning. So let's take a quick look at how you could do a policy like this. Let's see what I'm typing. Okay, so in this place, in the first case, I'm just apparently, I believe in creating a directory where the policies are going to be stored. So this is just going to be under C, under DG policy files. Or excuse me, I'm storing that as a variable. Next up, I'm going to be creating the path where I want the XML file of the empty device guard policy to be stored. So this is going to be just creating just a file path, essentially. That's going to be passed into the new CI policy. And so it's within this policy directory, so it's within DG policy files, and then we're creating this file at emptypolicy.xml. And then right here is going to be building out the path. Like Neil said, you do type a little slow on these videos. Alright, so now what I'm going to be doing is creating a new directory that's going to store the path to my empty code integrity policy. And so you can see that it's just created right now, there's nothing inside of it. And now we're going to go ahead and build the policy, the new CI policy. We're going to give it a scan path of an empty directory. The point being is I don't want it to actually scan any files, right? Because I'm creating a policy that's completely empty, that's just not going to pick up any sort of rules. So it'll by default block everything. And so again, I'm telling it to do it at the PCA certificate level, but it should find nothing. The scan path, this is where it's actually scanning to make the rules. And the file path is where it's outputting the file. And this is going to take probably 3 seconds versus your 3 days sort of to scan. And it's just going to find nothing, and the rules will be empty. And so that's super basic, but at least we're starting with now, at this point, with an empty code integrity policy. If this were to be applied right now on a device guard protected system, nothing would be allowed to run at all, including like your operating system, which you'll see. So the problem with this approach is it actually doesn't pick up all device drivers. So this is really weird, right? Actually, it's not. It makes some sense, because if we're only scanning an empty directory, it's not going to find any of the drivers because they're not installed there. So in order to do this, we actually need to go through multiple log files where drivers are being blocked to find and allow specific drivers. Matt Graber did a blog post on this. It was super interesting because even if you do scan like from the root directory or from a specific directory, this commandlet, the new CI policy, for some unknown reason, will actually miss certain device drivers and will prevent your computer from running. If you do it, you're going to see something like this, where I basically just sat here and watched for like 20 minutes, Windows continuously rebooting, saying it's preparing automatic repair, but because the device guard rules that were being enforced didn't pick up all the drivers on the system, it just continuously boot looped until you got into like a recovery mode to disable device guard, and then you could try to figure out what was going on. So each path has their own like strengths and weaknesses. Like it's really the common fight of usability versus security. In order to create there's no right way to create a code integrity policy. You really have to kind of figure out what works best for yourself. If you want to go with the gold image scan or not. The nice thing that you can do though is you could create a gold image scan. You're going to potentially pick up some unknown binaries that may be susceptible to application whitelisting bypasses. But like I mentioned earlier and showed the image, Matt Graber curates that rule set of applications that should be blocked, and that is actually a device guard code integrity policy. So you could use something like the merge CI policies to merge your rule set with his rule set containing applications that should be blocked, and you'll at least be protected at that point to stop the major ones from being used against you. So converting to binary. So now we have this code integrity policy. We've done the scan. Now we actually want to convert it into a binary format that Windows can use. So how do we do that? Well, it's super simple. It's just this Convert-CIPolicy is the commandlet that we're going to use. And this is exactly what it looks like. I actually have a video, but I think it's like 30 seconds. And all I do is this. It's not really a point to doing it. But so all I'm running is this Convert-CIPolicy. We're giving it the path to the XML file that we created with your new CI policy scan. And then all you just say is, hey, this is where I want the binary file to go. And it just does the conversion right there from XML to this P7B format. And now you're good and you can apply that in your environment. So now that we have a binary format, how can we go ahead and deploy this in your environment? Microsoft says online that you could use SCCM, I believe, and I've actually never seen an example of that being deployed, of it being deployed via SCCM. The method that I have tested in my lab, and again, I'm not a solid system administrator, so there might be other better methods, is use something like group policy and create a share in your environment and it only needs to be readable by the domain computer's objects. They don't need to have write access to it, but then that would allow them to read it, and you can just they can pick that up from anywhere in their environment. So let's take a look at how you could do something like that. So this will require, again, Server 2016 because it needs to be able to see that as a group policy option. So what I have in this case is CDG files. I have, there's my initial scan. Right here's my SI policy. That's the binary format of my device guard rules. If we look, I'm going to create a share. Well, I guess maybe it's not created yet, but I have domain controllers listed here, and domain computers, and they have read and execute rights. They can read, they can list folder contents. They don't have modification rights, but all they need to do is just be able to read this file. So we can go within group policy management, and we can just edit whatever group policy that we want, whichever policy you created, whether it be your default domain group policy or however you configured it. If we look within system, there's going to be an option right up here, which I'll scoot over for device guard. Basically, all we need to do is access this policy, and if we double click it, you can see right here we say we are enabling device guard, and when we do so, we have to specify the path of the scan policy that we're going to use. And so that's within that share that I just created. And so this will be deployed domain-wide to obviously any system joined to the domain that policy applies to, and it's going to start enforcing group policy, device guard on the different Windows 10 systems with that policy that we just created that path to. Oops. So again, here's just a screenshot of it, walking through the same path, or same steps. It's just a device guard, returning it on, and setting it up. Well, now that we've created the policy, we reboot our system. Like, how do we actually make sure that it is being enforced within the environment, that it's actually being applied? Well, one easy way to check is on a system where you didn't create it. Windows always stores your code integrity policy, the binary format, specifically at this path. See Windows System 32 code integrity directory, and it's always in this file called sipolicy.p7b. So we can check on any single system where that group policy should apply, and you should see this. If you see this, then that means that it actually is applied, or it's highly likely that it's being applied to your system, and that those rules are either being enforced or it's at least auditing rules. The better method is probably to review your event log. You can look under Microsoft Windows Device Guard, the operational log, and you should hopefully see this event ID 7010. And what it states is that, hey, Device Guard successfully processed the group policy, configurable code integrity policy. It was shown that it's pulling it from this path, and that the reboot was required, but it actually did successfully process it. And so these rules are either auditing executions or are enforcing rules within your environment. Great. So now we have these rules. We've created a rule set. We've converted it to a binary format. We've now deployed this into our environment. What if we need to make changes to the rules because we would otherwise be blocking users from just running programs that they need to get their job done? Well, let's look at how we can modify our policy. We might have missed an application, a library, or a driver. Specifically to see what we may have missed, we're going to be looking in this Applications and Services, Microsoft Windows Code Integrity Event Log. And so what we may see is something like this, where it says, in this case, Microsoft VS Code I tried to run, but I did not have installed on my system when I created my rule set. However, this would normally be blocked, but because my rules are not enforcing it, because they are auditing what's actually running, it says that the image was allowed to load. It did, however, create this event log event. Same thing down here with Chrome. Apparently I installed Chrome after I created my rules for my system, so Chrome would not normally be allowed to execute on this box, but because it's in auditing mode, it was allowed to run. So thankfully, again, we can easily parse the Windows event log with PowerShell. The new CI policy commandlet that we already ran to create our original code integrity policy has what's called an audit flag. And what this does is it will go ahead and parse your Windows event logs and look for any single file that an event was created for. If it finds events where that file should have been blocked but wasn't, it will then go to that file and generate a new rule for it, creating a new code integrity policy that contains everything that you missed the first time. Ideally, that's the goal. And so once we've created the new code integrity policy with our audit log, all we need to do is then merge the two rules together, your original rule set and your rule that you contain everything that you missed into one. And that's using the merge CI policy commandlet. So let's go and look. I'll show a quick video of that. Okay, so here's what I'm doing is I'm creating the new CI, or using the new CI policy commandlet. I'm specifying the audit flag here, and again, that's going to check the audit log for every single application that I might have missed. We're going to create rules at the PCA certificate level. Technically, you could create it at a different level, but I don't see why you'd want to do that. We're specifying the user PEs to say we want to pick up applications that might be used by users, and then we are specifying now the path to the output where it should create those rules. So we hit enter. This is going to be significantly faster than 3 days. This is going to take maybe 10 seconds right here. And so it's looking at all the different applications that we missed, generating the rules, and at this point, it's now complete. And I think it takes me a second to figure out. So it'll sometimes come back with something like this, where it says it may not be able to find rules for everything that was scanned. This possibly could be because an application is not digitally signed. It's also possible because you moved the location of the file from when it created the audit log. So now that we have it, you can see we have the audit sweep here. We have our initial scan right here. We're going to merge these two together into one larger rule set that hopefully would contain everything I need. So here we're calling merge CI policy. we're specifying the path of the first one, which is that audit suite, and then we're also specifying the path to you're specifying the path to the audit log, and then we're also specifying the path to that initial scan, which is this initial.xml. And now all it's going to do is we're going to tell it to output to a specific path after I fix my space here. And we just specify where we want it to store to. So it's going to go probably the same directory, and it's going to be like a merged file. We'll see in just a sec. Yeah. And so again, this is now in this XML format. And these are now all the rules that are within the updated code integrity policy. And all you need to do at this point is use that convert from CI policy to change it from this XML format into a binary format. Okay, and finally, so now that we've done our testing, all of our rules were deployed in audit mode. We created all these event logs. Now we have what we believe is our rule set that's needed that we actually want to enforce in our environment and start testing application whitelisting by enforcing these rules and not allowing anything to run. How do we do that? Well, we just basically set that one rule that changes it from audit mode to enforcement mode. The best place to start with doing this, though, and this is what I firmly believe when we talk to people or organizations about deploying app whitelisting, is targeting fixed functionality systems first. I mean, there's no reason for a domain controller to have Slack installed on it. Like, there's no reason for an ATM to have like the Steam game store. We can target fixed functionality systems where users aren't, that only need to run basically one thing, whatever it is to do their job. That's a prime candidate for application whitelisting because you don't have to worry about users needing to install different applications at any point in the future in order for them to do their job. The ATM just needs to run the one application that allows you to give money to whoever's using it. So, like I mentioned, the set rule option is the commandlet that allows you to enable or disable audit mode. All you need to do is run that against your the XML format of your code integrity policy, and it would work. And it would then start enforcing the rule set once you convert it into a binary format. So this is what it actually looks like if you have your rules in enforcement mode and you are testing to see if something should be allowed to run. So you can't really see it, but behind this is PuTTY. And so I created a rule set for my Windows system, did not have PuTTY on to begin with. Turned on enforcement mode of Windows Defender Application Control, downloaded PuTTY, attempted to run it, and this is what you or your users would see if they try to run something that's not trusted. It's just saying that we are using Windows Defender Application Control, and it's going to be blocked. And there's no way, in this case, for a user to say, like, allow anyways. It's not possible. The only way that you can get a change is to have a new code integrity policy created. This is actually what I see as kind of one of the most common complaints about device guard. And it makes some sense where it's a little bit harder to manage at times enterprise-wide because there's obviously a need for exceptions from time to time. Like users need to, or employees need to be able to have the ability to make an easy request for something that's needed for their job in order to do their work. Well, the easiest way to do that with device guard is unfortunately you have to create a new code integrity policy. Like we can basically follow those steps that we just went through, but somehow also pick up the file that they need to run. So that can be a little bit of an issue. So it's something to be aware of. But congrats. Basically now that you've done this, you've created a code integrity policy, and you are enforcing it, and hopefully it's helping to protect your environment. I know a bunch of friends that have worked at banks that have deployed not necessarily device guard, but other application whitelisting solutions. And the second that they start seeing applications that are blocked, that were attempted to run on a system that had this protection, like it's an easy win for them, and it's a way that they can show return on investment of the time that they spent to deploy this, because they're now preventing an incident from ever happening in the first place. So I firmly believe in this technology. I really think it's good, and you can use this to show wins. And if you get enough wins on your fixed functionality systems, maybe you can have the ability to start deploying it in your environment domain-wide. one other thing is, let's say you're in an environment where you have no ability to make change, right? Like, or maybe you just know from a management perspective, they're never going to allow you to deploy application whitelisting. Well, one thing that you can do is you can still use Windows Defender application control, and you can create your rule set exactly how you would want to have it create, right? So you can, any applications that you think that people need to have installed, just throw it all in, create a rudimentary code integrity policy, or if you want, spend the time to really make a pretty solid rule set, and then deploy it domain-wide. But the only thing is, instead of enforcing it, just leave it purely in audit mode. The nice thing about doing that is you're going to get telemetry on the different applications that are running within your environment that you would have normally blocked based off your rules. And the good thing is that this has no impact at all on users. They're still going to be able to run any single application that they want, but you as an administrator are seeing what would have been blocked otherwise, and you can start figuring out, okay, maybe that's an application that's actually needed, or this is a little bit weird, why are people running this? I might want to look into this a little more. It's basically a free Windows event log generator that you can use to see what potentially untrusted apps could be running. So I know Matt Graber has talked about it a decent amount. It's like, this is a way to test and try to help gain some insight. Alright, so subverting Windows Defender application control. I like, every offensive talk probably should have some form of a couple different slides on how you can defend against whatever you just talked about. I also believe in the opposite. A defensive talk should have a couple different ways, or at least a method that you can talk to about how you could try to subvert that technology or defensive capability. So there are a couple different ways you can try to subvert Windows Defender application control. The two primary ones are probably to develop an application whitelisting bypass or follow more of a living off the land approach. So what do I mean by this? Well, you can develop an app whitelisting bypass, and those are incredibly effective. And I hesitate to use it. It's definitely not a zero-day in the true nature of the term, or how people commonly refer to it. But you can think of, if you can find a brand new Windows application that no one has found before that you can use to subvert and run malicious code, it's kind of similar to one, because any sort of, think about it, most people trust Microsoft signed applications, right? They created your operating system. You're probably going to trust most of the binaries that they also created and are also installed in your system, unless you were to follow this default deny all policy. Well, if that's the case, then if you find something brand new, then you're going to be bypassing everyone's rules right now because your application is likely Microsoft signed. The big thing with going this route, though, is this takes research and development. This is time, aka this is money. So it's something that you have to be aware of, and you're not necessarily guaranteed to find something within any time period. But the nice thing is, if you do find an application whitelisting bypass, it's going to be 100% effective in its first use. However, similar to how developers patch applications, even if Microsoft doesn't want to service and fix whatever application whitelisting bypass you found, all someone needs to do is create a code integrity rule, just like what Matt Graber does, and block that application from running, and it's no longer effective. Another method of doing this is to live off the land. So this is the approach that I took, is I wanted to look at Windows Defender application control and figure out, okay, this is a good defensive technology. If I land on a system as an attacker, how can I attack this? And right now, there's not a lot of tools out there that allow you to survive or operate on an application whitelisting protected system. So I was trying to go through and figure out, okay, what is probably always going to be allowed and running? Well, PowerShell. Although this is going to be constrained language mode of PowerShell is still on it. I can also assume that WMI is going to be operational and running. It's a service that's been installed and enabled by default on Windows since Server 2000. So it is still operational and running. There are also potentially other Microsoft service and binaries, but these were kind of the two that I focused on. So I want to figure out, can I leverage these to attack a Windows Defender application control protected system? And I did. So I created this tool called WMI Implant. We'll show a video real quick, where it's a tool that is designed to allow you to attack these systems. It is completely written, very unfortunately, in constrained language mode, because if you've written in it, you know the headaches that it causes. But it uses WMI for everything. So it uses WMI to execute an action. We can start processes, we can kill processes, we can run different applications. We can modify the registry. You can do so much with WMI. It also uses it for comms, C2 comms between one computer and another, and it uses it for storage, or for like a temporary data storage area. The only thing is, a way that you can prevent WMI implant from working is by just blocking WMI. With that said, I've only seen that maybe a handful of times over the past few years in environments that I've tested where WMI is not actually allowed from one environment to another. That may be because administrators want to use WMI to pull and like gather health of different devices in their environment. It could be, I don't know, it could be a lot of different reasons, but typically WMI is enabled. So that's why we chose it. The only thing with doing this though, even if someone has WMI implant, it requires a much more enabled attacker, a much more prepared attacker to be able to effectively use it in an environment. Because when you first land on systems, you may not be expecting device guard, or you may not be assuming that all these different rules are going to be enforced on the system. So even though WDAC can still be kind of bypassed, you can have the ability to operate in that environment. And I still think that it's important to actually have and use. Because, again, even though it's bypassable, it's something that it requires an attacker to maybe make mistakes before they figure out what they can do to survive on that system. And those mistakes are what you're looking to trigger on and alert upon. So let's look at WMI implant and how it works. So I believe I'm going to show, I hope, that I'm in constrained language mode. Yes, I am. So this is validating that it is actually operating in constrained language mode, that it's that restricted version of PowerShell. And we're going to go ahead and run WMI implant right now. And so again, because this is constrained language mode compliant, we have all these different capabilities, and this can run and be allowed to run on a device guard protected system. So this is designed to be semi like a RAT, where you have the ability to read files. You can upload and download files. You can execute PowerShell scripts on systems and get the results back all in memory without ever dropping anything to disk. You can power off and on a system. You can run shell commands and actually get output back all using WMI. So like in this case, running ls, we're trying to do like a directory listing on the local system, and we're saying we just want to return stuff from the C drive. So here, you can see these are different files. We got like C windows, C users, different C scanner. All these are different directories that are in here. The next, we'll look at a different command that we can run. We can run like ifconfig. So this is again super basic. This is running against my local system, and it's returning every single NIC that is active on the system. So right now it's again super basic stuff, but this is kind of like the information gathering phase. Well, let's look at installed programs. We can see if there's anything that's interesting that's on the system that we can use to maybe attack or do something with. And so it's pulling back the different applications that are installed. This system, apparently when this ran, I had very little programs installed on it, but we can see we have Google Chrome, like a C++ redistributable, and other minimal stuff. Next up, we're going to, I guess let's see what we're going to look at real quick. I think we're going to start a process. Yeah, so we're going to start a process. And so this is how we can do basic process creation. One thing to note is, in this case, I'm doing everything on localhost, so the local system that I'm on. This will completely work remotely. Assuming that you have admin rights on the system that you're targeting, you can run every single application, or run all of these commands against any system and get all of these results. So I actually commonly do this before I jump from one system to another that I'm compromising. One of the things that I'll look at is you can perform like a process listing, and so you can see what applications are running before you attack it. And it's kind of nice because you can see, are there any defensive products that are actually deployed on here, and how can I possibly circumvent them, or just know what I'm getting myself into before I get on the box. So in this case, I'm starting Notepad. It said it was successful with the return value 0, and we can see Notepad was started. So you can use this to run any application, such as PowerShell or anything else on a remote system if you really wanted to. Right now, I'm just going to probably kill the same process. So this is stopping Notepad, which you can't see, but this return value of 0 said that it was successful. So it actually did stop it. And finally, this is the other thing that you can do is this command exec command allows you to run a command. It also allows you to actually get output. So, like I was explaining this in my workshop, I like to think of like starting processes on a system, especially remote systems, as blind process creation. What I mean by that is when you normally run a command like ipconfig or any other binary on a Windows system, you get the output, right? Like you can see what your IP address is or whatever it is the output that you're expecting. However, when you do so over WMI, you don't get any sort of output at all. What you'll see, or what you just saw, like when we started Notepad, is all you get. So you have a return code of 0, the process ID of the process that you started, but if you ran ipconfig on a remote system, you're not getting its IP address information back. You're just saying, yes, it was run. So what I wanted to solve was, how can I run commands on a remote system and still get the output back from it? And this was solved by shoving, long story short, taking that data, storing it in a specific WMI property, and then retrieving it. And you can do this all remotely or locally. And so here's an example of running this ipconfig command, and we are actually, in this case, going to get the output from it. So you can use this to execute any sort of command at all on any system, locally or remotely, and get output. And that's actually really it. I hope that this kind of helps explain what device guard is. It's a free application whitelisting software that's available on Windows 10 Server 2016. And I wanted to kind of just walk through how you actually create rules, how you can apply them to a system, how you can start enforcing them, and how you can also bypass this. We actually have a couple different blog posts on our website if you want something more than just a video or this talk that walks through the different steps, again, of creating an application or creating a Windows device guard protected lab environment and how to create code integrity policies and basically apply them to your environment. So I hope this helps. Thank you for taking the time to attend my talk. And if you have any questions, feel free to talk to me throughout the day. I'm happy to help answer. Thank you.